Hello everyone, this is Shreyansh and my friends Mosharraf and Rajeev are here to give you a presentation on the review of a paper on modeling and evaluation of energy policies in green clouds. I would like to give you an outline of our presentation, which we will be starting with introduction, and then we will move on to the literature and related work in this area. Then we will be going to the theme and defining the objectives and the design, which will contain existing design and the proposed design of the by the paper, and then the result analysis of the paper and the conclusions, and then finally we will mention the references. Before we start, we need to know that what is cloud computing. So computing is basically a kind of internet-based computing that provides shared processing resources and data to computers and other devices on demand. Also, cloud computing promises several attractive benefits for businesses and end users. Now, to mention some key features of cloud computing, I would say they are: first is the pay-per-use, second is software as a service, and third is infrastructure as a service. The cloud computing has enhanced the ways users use softwares and their data very nicely, as all the data is backed up to the clouds and it is very safe and secure even if it gets deleted on the local machine. Now we would like to touch upon the areas where green methodology can be applied. So green computing can very well be integrated with cloud computing, also be used to enhance data center efficiency. The green computing can be clubbed with workplaces, and green computing is also applicable with telecommuting. Telecommuting is basically attending or interacting with something which is remote in a remote area from you without being physically present at that place. In this context, cloud computing is emerging as a promising paradigm able to rationalize the use of software and hardware resources, handling load peaks, and reducing data center inefficiencies due to low resource utilization. Hence, green methodology is very efficient in saving the energies and also the costs of the companies. And also, energy saving is one of the most critical challenges of the 21st century, and hence green computing fits just right in. So, implementing green computing or going green is not just as straightforward, easy as it seems. There are some issues involved. Some primary issues in going green are problem of assessing the quality of service offered by the cloud computing. Powerful strategies are needed to guarantee the SLAs. Also, traditional measurement-based performance evaluation requires extensive experimentation with different workloads, which might not be favorable with green computing. Simulation model has to be developed, which will be very time consuming in order to implement green computing in the areas of cloud computing. Now, we would like to discuss that what is the driving factor or the motivation to for implementing green computing with cloud computing. So, cloud computing addresses two major ICT challenges related to green computing, being first being the energy users and second being the resource consumption. And also, the motivation is virtualization, dynamic provisioning environment, multi-tenancy, green data center approaches are enabling cloud computing to lower carbon emissions and energy usage up to a great extent. And also there are some facts due to which we are very highly motivated to implement green computing. Like large enterprises and small businesses can reduce their direct energy consumptions and carbon emissions by up to 30% and almost up to 90% respectively by moving certain on-premises applications onto the cloud, which will reduce the workload on the hardware of the company locally, and all the computations or the processes will move on to the computers or the hardware which is stored at the cloud.
Hello everyone. Apart from the original paper, we have also studied other related papers. The first one is Green Cloud Computing and Environmental Sustainability. Okay, now the growing demand of cloud infrastructure has drastically increased the energy consumption of data centers, which has become a critical issue. High energy consumption not only translates to high operational costs, which reduces the profit margin of cloud providers, but also leads to high carbon emissions, which is not environmentally friendly. Hence, energy efficient solutions are required to minimize the impact of cloud computing on the environment. In order to design such solutions, deep analysis of cloud is required with respect to their power efficiency. Thus, in this chapter, we will discuss various elements of clouds which contribute to total energy consumption and how it is addressed in the literature. We also discuss the implication of these solutions for future research directions to enable green cloud computing. The chapter also explains the role of cloud user in achieving this goal. The other paper is a Green Cloud Framework for Improving Carbon Efficiency of Clouds. The energy efficiency of ICT has become a major issue with the growing demand of cloud computing. More and more companies are investing in building large data centers to host cloud services. These data centers not only consume huge amount of energy but are also very complex in infrastructure itself. Many studies have been proposed to make these data centers energy efficient using technologies such as virtualization and consolidation. Still, these solutions are most cost-driven and thus do not directly address the critical impact on the environmental sustainability in terms of CO2 emissions. Hence, in this work, we propose a user-oriented cloud architecture framework. The theme of this paper is to develop novel energy efficient management policies that improve the performance of cloud computing. The objectives of this paper are to study energy efficient techniques for cloud computing. Second one, to study various energy policies of infrastructure as a service. Third one, study background of Petri nets. Fourth one, analyzing and modeling green IaaS cloud scenario. And the fifth one is to analyze the results for performance parameters. Modeling the green IaaS cloud. We exploit layer by layer approach by separating concern according to physical layer where energy and PM specific are dealt with. In this, we have to define how the switching network is implemented, while other layer is the virtual layer where all the aspects related to virtual resource management are dealt with. Virtual layer manages the IaaS request. Workload of generation data centers typically display intermittent examples with a period time of 1 day. The request scheduler subsystem is spoken to by displaying an arrangement of queues, the distinct administration classes, each of which is related to an alternative line, and their need mapping can be demonstrated by setting the needs of a quicker move.
Hi guys, this is Rajiv. I'm here to speak about the methods and conclusions of this particular paper. The factor of energy efficiency is not considered at present. High energy efficiency is not considered in designing a cloud computing system. Example, some resources may be low in utility for a long time while the system is in high power state. It may not waste too much energy for a low scale system. However, it may waste too much energy for cloud computing environments. An IaaS infrastructure as a service cloud provider, while managing his or her data center, puts into action a set of policies with the goal of jointly optimizing the quality of service, parameters, and energy consumption. Graphically, a PM is a directed bipartite graph with two types of nodes, places and transitions. A directed are connecting a place, a transition of a place is called an input or output arc of the transition. Proposed design of this system is we have IaaS infrastructure as a system request where a customer requests for the particular scheduling. Then a particular scheduling will be including the service classes and then the resource will be allocated to them via VM. It will include hypersupervisor, physical machine and power. Power can be on or off and then the data will be stored onto the storage into the file system. This distributed file system can be accessed from anywhere because it's a cloud computing system and it will include it will be high speed network. In this way, cloud computing helps organizations to save 60% of their data. Results are assessment led through modeling can be performed in two distinctive ways, simulative versus analytic analysis. While simulative methodologies for the most part permit the modeler to embed the same number of subtle elements and essential in the portrayal of the framework, numerous simulation runs are for the most part important to acquire factually huge results. On the other side, regardless of the possibility that analytical modeling is portrayed by a more relevant amount of reflection of the framework. The lower arrangement cost permits to cover a bigger parameter space than simulation. Thus, in order to demonstrate the accuracy of our technique, we first compare the results obtained by analytically solving the SRN model proposed in the previous section through the use of SMPN tool against those obtained by simulating the use case with the Cloud Sim framework. Then we compare the two approaches with respect to the execution time, showing that the SRN model exhibits a better scalability against the complexity of the considered scenario. By watching the results, we can contain that the analytical results are inside the certainty interim of the simulation results, except for few focuses. This exhibits the adequacy of our modeling. Now we are moving to conclusions. This work displays an analytical framework in light of SRNs that permits to foresee the expenses and advantages of various policies, both from the client and the supplier's point of views. An acceptance against the cloud system framework was given. Future work will concentrate on modeling, accessing, and looking at management policies received in genuine situations. Cloud computing business potential and contribution to already distributing carbon emission from ICT has led to a series of discussion whether cloud computing is really given. It is forecasted that the environmental impressions from server farms will triple between 2002 to 2020, which is currently 7.8 billion tons of CO2 per year. There are reports on green IT analysis of clouds and data centers that show that cloud computing is green, while others show that it will lead to alarming increase in carbon emissions. References used to build this paper are by X9, C. Iski, Gephardt, L. Zhang, E. Bulliet, and D. Penderakis. Efficient resource provisioning in compute clouds via VM multiplexing. Another paper by D. Bruno, M. Fazio, F. Longo, and A. Piliofito. Smart data centers for green clouds. S. Takeda and T. Kakamura. A rank-based VM consolidation method for power saving in data centers.